let's have a look at how to use Ohm's law and Watt's law as quickly as possible, where E is equal to voltage measured in volts, R is resistance measured in ohms, and I is current measured in amps. P is our power measured in watts, I is the same as in Ohm's law, current measured in amps, and E is still our voltage. And these nifty little formulas, the way that they're drawn, work quite nicely to help you determine whether or not you need to multiply or divide to calculate for missing values. So if we are looking for our voltage, we would multiply our amperage by our resistance, and that would give us our voltage. If we're looking for our current, our amperage, we would divide our voltage by our resistance. We're looking for resistance, we divide the voltage by the current. Watt's law works the same way. If we're looking for power, we multiply our current by our voltage. If we're looking for current, we divide our wattage by our voltage. And if we're looking for our voltage, we divide our power by our amperage. Let's have a look at how this works. Let's say we have 12 volts and we have a resistance of 10 ohms. To calculate our current, our formula would look like E divided by R equals I. Or you could write it as I equals E divided by R. 12 volts divided by 10 ohms gives us a current of 1.2 amps. If we are looking for our voltage, and let's say we had a current of 6 amps, we have a resistance of 10 ohms, our formula, we're looking for our voltage would be E equals I times R, which would give us 60 volts. Watt's law works very much in the same way. If we're looking for the wattage of this circuit right here, so we would have P equals I times E, which is 6 amps times 60 volts, and that would give us a wattage of 360 watts. So that's all fine and dandy, but what if we're trying to calculate power and we don't have our current and our voltage? What if we have our voltage and our resistance? Well, what we could do in this situation is we could use Ohm's law to calculate our current, and then we would input our current into Watt's law to calculate our wattage. So we have to make 2 steps now instead of 1. So looking for current, I is equal to E divided by R. I is equal to 12 volts divided by 10 ohms. I is equal to 1.2 amps. Now we're looking for our power. P is equal to I times E, our current times our voltage. P is equal to 1.2 times 12. P is equal to 14.4 watts. Excellent. Now what happens if our needs are a little bit more complex? Let's say we are trying to find our amperage. We have our power and we have our resistance. How do you use that? Because we have resistance, but we don't have power here. We have power here, but we don't have resistance. That's when we would need this lovely power wheel. And this is a little bit more complex with its formulas, but it enables you to make pretty well any calculation bypassing the 2 steps of having to use Ohm's and Watt's law together. So in this scenario right here, we are looking for our current, which is I, which is this part of our power wheel. We have P and we have R. So that would be this formula right here. So we would go square root of P divided by R, which is the square root of 10. Punch into our calculator, a square root, 10 equals 3.16, and we're just going to round it off there. And that is our current. So that would be amps. And it works very much the same way for any portion of the power wheel, where you just have to look for your knowns to find your unknown. So if we're looking for our voltage, we could use any of these formulas here. If we're looking for our resistance, it would be any of these formulas here. Looking for our power would be these formulas. And there you have it. A quick, dirty, how to do your Ohm's law and Watt's law calculations. Hope this helps. Thanks for watching. Hit that like and subscribe button on your way out.